So when you have a public class name, does it need to be called that?
No, if you remember, the fact that it was called public class main here was something that online GDB does. Whatever you name here just has to be the name of the file. But the file that you run has to have a main method.
How does it know that that's
Because you can only have one main method. If you have more than one main method in a package, it's going to freak out. All programs begin and end with main. That's the punchline for all C-based languages. So the very first thing it's going to do is it's going to look for the main method. It does not have to be in a class called main. I think I mentioned I typically will put it inside of a class called driver because that's the class that drives the program. But online GDB names your base Java class. When you create a Java project, it names it main.java. And in Java, whatever the name of the class is, so if it's main.java here, it has to be public class main here, capital M. That's the match. But this is not a Java rule. That this is a online GDB thing that's having that class name main. I typically would not create this confusion between a class being called main and the method being called main. But the important rule is that you must have a method called main, public static void main, inside of the class that you mean to run for your program, and there can only be one of those. Well, then main would be a thread. Yeah, under the hood, when it runs, when the Java virtual machine runs the main method, it will create a thread in which to run this. Main itself is not operating as a thread by itself. It's the way it gets launched that makes it kind of the main thread in the program. Sure, this is saved here. All right, so let's get our monsters cooking here. So now that we've seen our threads, am I sharing my screen? Am I recording? Yep. All right, so now that we've seen our threads, right now we have a monster. A monster has a name just like any inhabitant has a name. And if you remember here inside of our player, which is human controlled, we wrote a function called play. And we decided that that this is going to be the guy that's going to basically have the infinite loop asking the human being, what should I do? What should I do? What should I do? And allowed us to dance around the dungeon and all that stuff. All right. So we want monsters to differentiate themselves from players. So we can call it play if we want, or we can tell a monster to start, something like that. Or maybe tell a monster to go. Let's I don't know. I want to keep the name distinct. So let's call go. So we're going to say public void go. All right. And what this guy is going to do, it's going to start this monster on a thread and make it do whatever monsters do. All right, which might be that it sits there and it waits for 3 to 8 seconds and then randomly chooses a direction and then takes that exit, moving from one room to another room. That might be what we have our monsters do. That way you kind of have this liveliness of them going through there. All right, so how are we going to accomplish it? We need to give kind of life to our monsters, and we do that through a thread. All right, so what we're going to do is we're going to update our worker bee here to no longer take a name in. Instead, we want this guy to take in a monster. All right, so we're going to have a private monster. Call this guy the monster. And we'll set this dot the monster equal to the monster. All right, so when we build a worker bee inside of a monster, the monster is going to let that worker bee know about itself. Okay. So let's go ahead and do that. So inside of Go here, we're going to create a worker bee. Call it WB is equal to a new worker bee. Now, worker bees, as we've just updated them, when they are built, they require us to pass it a monster. So from inside of monster, how do I let this worker bee know about the appropriate monster? Using this keyword. All right. So when we build this particular worker bee inside this particular instance of monster, we're going to pass ourselves in to that worker bee. So it has access to the figure, the character that we want to dance around the thing. Now, inside of our worker bee here, we've seen that inside of run, we could do some stuff, right? We put some thread sleep stuff in there last time, whatever. But ultimately, what we want to do here is we want to ask the monster to do some stuff. Maybe look at the exits inside of the current room in which the monster resides. Just like players live inside of a specific room. Let's see, where do we have? Is that at the inhabitant level? Yeah, inhabitants, all inhabitants know about the current room they're in. So whether you're a player or a monster, you know the room you're in. So if every 3 to 5 seconds, let's say, I wake up, I'm a rat, I'm one of the monsters. I wake up and I say, all right, room, I'm going to guess at a direction. You tell me if that's one of your available exits. If it is, I want to take that exit. I want to leave this room and go into that room. All right. So effectively what we'll do is every 3 to 5 seconds, we will have a monster roll the dice to give us a number between, 0 and 3 or 1 and 4, however you want to do it, and have that line up to a guess of either north, south, east, or west. Okay. And then we'll tell the room that we're in, all right, I want to go to the north. There might not be an exit to the north, but we're going to tell the room that's where we want to go. The room's going to then do a search to see, does it have an exit to the north? If it does, it'll then it'll have that monster take the exit, just like players take exits. All right. If it doesn't, we'll probably, since it's a monster and it's computer controlled, we probably won't give any feedback. We'll pretend like it slammed into the northern wall and didn't go anywhere. So we won't actually take it out of the room and any of that stuff. But effectively every, however long we decide to make it, every 3 to 5 seconds, maybe make it a little bit longer. We'll probably make it short initially just so we can see things running around the world and have a decent chance of a rat entering the room, that kind of stuff. But, we'll randomize where we'd like to try to go, and then we'll try to go there. All right, so from a worker bee's perspective, I'm going to go ahead and I'm going to create a array, and I'm going to fill this array up with north, south, east, west. All right, so we're going to say we're going to have a string array called directions, and this guy is going to be equal to north, south, east, west. All right, so that's how you could hard code an array and just get some initial values in there. All right, so bucket 0 is north, bucket 1 is south, bucket 2 is east, bucket 3 is west. All right, so while we're in this loop, after we sleep for some period of time, then we want to roll a random number between 0 and 3 inclusive. And grab that direction that we want to go. All right. So this was our timer for how long to sleep, correct? So we were sleeping for, remember, this is milliseconds. So we are sleeping anywhere between what, like a third of a second up to a little bit more than 2 seconds. We'll keep it at that for now. That's going to make the rats at least have a chance of taking some exits fairly quickly. We might have them running all over the place. All right. So we'll go ahead and sleep. Now, when we wake up, we want to pick a random direction. All right. And we do this by rolling our dice, right? So we can say int, well, why don't we do this? String direction is equal to directions at bucket r dot next int 4. So r dot next it passing it a 4 is going to give us a number 0, 1, 2, or 3. It just so happens that we have bucket 0, bucket 1, bucket 2, bucket 3 in this array. So we're going to randomly pick north, south, east, or west. And that's going to get put inside of this string called direction. All right. And if we want to see this, I can say I'm gonna try to go to the direction. Okay. Now, the reality is a monster already has a name. So if you look at this, we have a get name, right? Instead of inhabitant. Yeah. Inhabitants have a get name. So we're going to add that to our worker bee. So we're going to say this dot the monster dot get name. Name's a private field inside of inhabitant, so we can't use that directly. We can't say dot name. We need to use the public getter called get name, which was provided to monster from inhabitant, and we have access to it through our instance of monster here called the monster. So we're going to say the monster is, say, going to try to go to the east, north, whatever. So presumably we're going to build a monster called like rat. All right. And, you know, the rat is going to try to go in these different directions. Maybe we'll, for testing purposes, we'll create 3 different monsters, maybe like rat, frog, cat, something like that. So we can test it from within main before we throw these guys into our actual dungeon. All right. So following what's going on here, we're going to go to sleep for a third of a second up to 2.5 seconds, whatever it is. Then we're going to pick a random direction, north, south, east, west. And then we're just going to print out that the rat is going to try to go to the north. Something like that. Frog is going to try to go to the east. That kind of stuff. This is, thank you. All right, so that kind of stuff. That's what we're going to try to pull off here. Then what happens? It loops back up, goes to sleep again. All right, well, it sleeps right here. So it generates a new wait timer, goes to sleep, yada, yada, yada. All right, this is what worker bees do right now. And it is a monster, when we tell it to go, that creates this worker bee and then says WB dot start. The monster turns on its engine, turns on its brain, whatever. He comes alive. Frankenstein's monster. All right. Makes sense how this is going to work. All right. So we're going to create a couple of instances of monsters. Then we'll tell those monsters to go. The go function generates the thread inside the monster and then starts that thread. So we'll do that inside main for right now. So we're no longer going to have worker bees in here. We're now going to have a monster M1 is equal to a new monster. Let's call this guy a rat. M2, M3, call this guy a frog and call this guy a cat. Then we'll tell each of those guys to go. All right. Now we just named it go just to keep it distinct from some of our other things so we don't have confusion. Go is a function we wrote. It doesn't have anything to do with threads other than the fact that we did thread stuff in here. All right. We put that logic in there. All right. So what we should have is every third to a little over 2 seconds, these guys are going to start randomly saying they're going to go in some direction. They're not actually going anywhere yet. They're just doing a whole lot of talking. So let's just see it work, and then I'll come to you. Rad is going to the southwest, east, blah, 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 blah. These guys gonna be zipping all over the dungeon. You're not even gonna have time to attack them. That's gonna be even better. You put them on an aggro. They just come in, they just like slash you and then leave. Just later.
Give a second to type in the
All right. Good. You have a question?
So why don't you just call the run method instead of doing start? Like, why do you have to do start?
You mean inside of Monster here? Why did I say start instead of run?
Yeah.
That's the we talked about it last time. That's the magic. The Java virtual machine knows how to talk to the underlying operating system, but it does that through that start function. The logic it performs is the logic that's inside of run. But you need to call start in order for him to talk to the operating system and ultimately schedule that guy as a thread and not just something else. So really, we can really say it's magic, right? Inside of that thread class, which has a start function, it knows the magical words to speak to the operating system to actually create an operating system level thread that gets scheduled on the processor.
Is not like the class worker bee is not a.
Yes.
So, like when you do like worker bee WB worker bee, I mean, aren't you making a thread?
I'm making an instance of our worker bee, and a worker bee is a thread.
Yeah, so
Therefore, he has a start method. Even though we didn't write the start method here, we wrote run. The start method calls a thread's run method. That's what it does. So we said that a worker bee, we want you to actually be a thread. We are going to differentiate you from a generic thread by saying you're going to keep track of a monster. And we build that inside the constructor here. And then this is what we actually want you to do when you start. All the stuff we've put inside run. That's what differentiates a worker bee from a generic thread. A generic thread has nothing inside a run. So when you start it, it's like, hey, I'm a thread. Now I'm dead. I'm gone. Because there's nothing for him to do, so he's not going to get scheduled. Now we have stuff for him to do. Make some sense? All right. Oh, yeah. And try to keep in context of when we went into threads. So yes, we're talking about threads, but I don't want to get too deep into what a thread is because that's really something you talk about in the 350 class in terms of how process scheduling works and thread scheduling on operating systems and stuff. For our intents and purposes, a thread lets more than one thing happen at once. Really, what we want to focus on here is that inheritance model. Okay, a worker bee is one of these thread things that the Sun Microsystem people created. And he gets all the magical stuff that came with that guy, but we can kind of tune it to do some specialty stuff like having monsters pick random directions. All right. And then the extra special thing we just need to make sure we do is when we jumpstart that thread, we do that by calling the start method. That's kind of the specific thing that we need to know about threads specifically. Is the start method is what actually has to get called, and it will do the job of calling your run method. Because somewhere in the middle there, we needed to talk to the operating system to do some stuff to allow things to happen at one, multiple things to happen at one time.
How does it connect dots and start into your run function? Is the run like a keyword searching for it?
The start method inside of thread calls run. That's what he does. No, if we say run LOL, now it's broken. Yeah, it'll call thread's default run method that does nothing. Yeah, so effectively what we're doing here is called method overloading. We are redefining the run method to do something rather than nothing. Because we did get a run method from thread because we are a thread. This dude's a thread, so he gets a run method that has nothing in it. And when you start this worker bee, it's going to call that run method that has nothing in it. Big old waste of time. All right. But we decided, you know what? I want my run method to I want this thread to do something. So we overloaded, sometimes it's called override. We redefined the run method to do the stuff we wanted to do rather than the default stuff that came with the thread. Okay, so realistically, a thread is, in fact, I'm trying to think when we might use a thread otherwise. You could probably make a decent argument for thread to be an abstract class. In fact, actually, you know what? I wonder, is it an abstract class? Let's look real quick. Then we'll talk about what it means. Anybody want to remind me what an abstract class means? In this case, you actually can. It's not an abstract class. But what does the abstract keyword ultimately mean? What does it do? Yeah, so effectively, when a class is abstract, which thread is not, this is not an abstract class. I'm not sure why. We could probably do some looking in here and figure out what other uses you might have for a thread. But generally speaking, the way I'm at least kind of teaching it to you here is you would never just have a generic thread. You would have things that are threads, right? We have a worker bee that is a thread. So it would never make sense for us to make a instance of thread, just like it doesn't make any sense for us to have an instance of our inhabitant class. So we made inhabitant abstract, at least we better have. Yeah, so that guy's an abstract class, which means you are not allowed to create an instance of it. Not only shouldn't you, it'll scream at you if you try. All right. So realistically, you never actually ever have to make something abstract. It's almost kind of a self-policing thing. It prevents you from doing something that you didn't intend to do. I don't want to spend, we probably can dig in and try to find out under what circumstances might you create an instance of a generic thread. I'd have to think about it some. I hope there is an argument for why you might do that, but right now, I don't see any reason why you'd ever have a generic. You know what? You can do what's called a closure. You can create a new thread and inline redefine the run method. That would be absolutely ridiculous to do it that way, but technically you can do it that way. If you've had other languages like JavaScript, these are called callback methods. Yeah, pretend like that doesn't exist for right now because it's stupid. But I can see under that very special lazy circumstance, you could create a instance of a generic thread and inline redefine the run method. That's allowed in Java, even though it shouldn't be. So this should be abstract. We're going to give the original Sun Microsystems people a D- for writing this class. All right. So there's our worker bee for right now. A monster, when we tell it to go, he wakes himself up, sparks his worker bee-ness. Well, actually, he creates his worker bee-ness. So this is sort of kind of when, this is like the Frankenstein monster, the electricity lightning bolt thing hitting. He poofs to life. What happens? We tell that worker bee to start. The worker bee comes in here. He calls his run method. That's what that start method from thread does. So that's the automatic magical little thing that happens. Call start, it calls run after talking to the operating system to build a thread. All right. And now we've seen that this guy is going to pick some random directions. All right. So now we need to have, well, now that we have a random direction, we want to be able to try to take one of those random directions, right? In order to do that, we have to be in a room. When I say we, if I'm a monster, if I'm an instance, if I'm rat here, okay, and I at first I need to get put into a room, and then I can start having a little bit of a negotiation with the room of, hey, I want to go to the north or go to the west or whatever. And the room can kind of say whether or not it has an exit there, and then do the stuff to move you from one room to another. And that at that level, very, very, very similarly to what we do with players. We remove a player from the current room, we put them into the destination room. Make sense? All right. So let's get our monsters into our dungeon, which I actually think was part of your assignment a couple of assignments ago when we were just making it very generic. But I don't think we actually did it in class. I think we built all of our rooms and put the player in there, but never actually threw a monster in there. All right, so let's go to main. I'll just go ahead and steal these couple of monsters. We're going to go into dungeon. Here's where we populate the CS department. All right, so we built a bunch of rooms. We built a bunch of exits. Where do I put the player in here? That's where we add the player. Do I do that from main? Yeah. Okay. All right. So I have my player. I tell it to add the player. I think I'm going to keep my monsters inside of the populate CS department. That way we have proper monsters roaming around. All right. So inside of populate CS department, let's say we're going to call this build monsters. And we'll go ahead and throw our couple of monsters in here. All right, and so we're gonna have Dr. Locklear, Dr. Wall, and then Mr. Gonzalez. All right, so we have some monsters that are ultimately going to go into our dungeon. All right, but now we need to actually be able to add them into our rooms. So we're going to kind of sprinkle them into the rooms where we want them to be. Let's go and look at room real quick. In room, we have something called add player, which specifically adds a player to a room. Notice that if you remember our design decision, we decided to have a separate array for players and monsters rather than a single array of inhabitants. Could have gone either way with it, but we chose to have separate things. So that means we need to come in here and we need to teach a room how to add a player or add a monster, sorry. So we'll say public void, actually, we could probably just steal this dude. We'll call this guy add monster. This will take a monster M as a parameter. We're going to add this guy to the monsters array. And then we'll increment our number of monsters. And then we're going to tell that monster who his current room is. All right. Now, remember, set current room is something that happens at the inhabitant level. All inhabitants have the ability for us to say, here is your current room, whether you're a monster or a player. All right. So when we add a monster to a room, we're inside of a room right now. We take a monster in as a parameter. We add them to the next available bucket in our array. We increment the number of monsters, and then we set that monster's current room. All right. So go back to our dungeon here. After we've built our rooms, we'll just go ahead and say place monsters in the department. Perfect. All right. And we can just randomly decide where we want to put them. So maybe S118, add monster, M1. And maybe we say H3 dot add monster, M2. And we say maybe something in the entrance. That way we can see them immediately leave or within 3 seconds when we first get in there. We'll say entrance, add monster, M3. All right. So all we did here is after we built our rooms, we just picked 3 of them kind of at random and placed our monsters in those 3 rooms. We haven't told those monsters to start kicking yet, right? We haven't hit them with the lightning bolt. Okay, we've just placed them inside of the rooms. Go ahead.
So can we randomize rooms?
Sure. If you wanted to do that, I don't remember. Are we keeping track of our rooms inside of our? We do have the rooms. Are we actually using that? I think add room. Yeah, this puts it into the room array. So we are adding it to that room array here at the bottom. So we could generate a random number between 0 and the number of rooms -1 and pick a room at random and say, okay, M1's going in there. All right. So we could do that if we wanted to. And I'll add to our comment here in case we need to access the entire collection of rooms. That's why we're putting them in an array of rooms. Okay. So now we've placed our monsters. And if we want to, I'll go ahead and just in case you want to do some random stuff like that, I'll put our monsters in after we've added it to there. Okay. At this point, all the rooms exist, all the monsters exist. Are we keeping track of? I'll probably go ahead and want to ignite my monsters here as opposed to having them asking the dungeon to wake all monsters, something like that. You know, we can tell our dungeon to start cooking. And do we have a method that does that? Or do we say like populate the department, then we have our player, we tell our player to play. All right. So I mean, we could write a function inside of dungeon that says play or start or whatever, begin. And then that guy could go through all the rooms and all the monsters in all the rooms, telling each monster to go, which starts its thread. In our case here, rather than do that, we have 3 monsters. Let's just get them going. All right. So we have 3 monsters. inside of populating the rooms. We picked very specific monsters that are appropriate to our dungeon. So the very last thing we'll do before we finish this populate CS department is we'll hit our monsters with the lightning bolt. M1.go, M2.go, M3.go. So we'll say wake monsters up. That's effectively what that does, right? All right. Now, just as a reminder, let me look at room here. When we display a room, so we ask a room to display itself. We say, here's the room's name. Here's our obvious exits. We build up that exit string. Here's our players. Now we're going to have also a collection of monsters that are in this room. Okay, so we're adding to our room's display method to add an additional line for any monsters. So I'll just copy this guy here. We'll call this guy build our monster string. And why don't we call this guy lurking around, something like that, just to differentiate. Also here is always players. Lurking around is maybe monsters. We want to keep them separate. So we'll have our monster string. We'll go through the current number of monsters. Monster string, the monsters. So we'll ask a monster for its name as we're building up this monster string. So we'll go through all the monsters. Each time through, we'll update our monster string with a particular monster's name, followed by a space. And then we'll make sure that we spit out the monster string. All right. So we just taught rooms how to display themselves better now that we have monsters lurking around, as I put it. Okay. So we've created some monsters. We've added them to a couple of rooms in our dungeon. We've sparked them. At this point, they're not actually doing a whole lot except babbling about trying to go in different directions. Okay, but they're doing it. They're every third to 2.5 seconds, they're trying to do that kind of stuff. But our players should be able to now see the monsters that are lurking around in there, but the monsters aren't actually moving yet. All right, so out in main, let's go ahead and run this dude. All right, so you see, we see lurking around Mr. Gonzalez there in that first room. That is the worst guy you want to run into in room one. All right, so now we see Mr. Gonzalez, Locklear, all these guys. They're babbling a whole lot about going in some different directions, right? Okay, now right now we have this this commentary of them trying to do something, so we know they're kind of alive. We probably don't want to have that later on, because it gets in the way of our of our room that we're looking at here. What we probably would want to have happen is when when Mr. Gonzalez leaves the room, maybe something spits out to the screen that Mr. Gonzalez leaves to the north, right? A single one-liner, not something that's popping on the screen every 5 seconds, getting everything to roll by, right? All right. And then maybe if you're in the room to the north and, might say something like Mr. Gonzalez arrives from the south, right? Got to figure out what his weapon would be. He might be like juggling chainsaws. That sounds like a Mr. Gonzalez weapon. How many of you get the Chucky reference? 2.5 people. It's a child's play from the 80s. Maybe the last one was in the 90s sometime. Yeah. Well, they did have a reference to it in the movie Ready Player One. It was not in the book, but in the movie, yeah, they somebody had like during the war at the end, somebody had like a toy thing and they threw it and it's like, hey, try this. Like, oh, there were some explosives. It's Chucky. He was stabbing at him. It was pretty good. Yeah, that's basically Mr. Gonzalez. All right. So that is the current state of things. So now I'm going to save this. So what should happen next? We want to, for our homework, so we'll say, given this guy's your starting point, make the monsters actually try to move, well, let's say actually move from room to room, given the random directions they are currently claiming they want to move. When a monster successfully leaves a room, it should announce something like Mr. Gonzalez has left to the north.
Would it be better if they didn't announce the direction they left for us and then
This is just a random, or throw some Harry Potter and Mr. Gonzalez disapparates.
Oh, yeah.
You can take some liberties if you'd like to have some fun with it, but something along these lines. Have some way of knowing that a monster's left the room. All right. When a monster successfully enters a room, it should announce something like Mr. Gonzalez has arrived from the south. Submit a link to the code and the self assessment. All right. So after we've completed this is going to be our last Java assignment. So what we'll do next week is we're going to get Unity installed.
I didn't get that. Could you try again?
No, I refuse. Let's see, is next, when's spring break? Not the end of next, not the week after next, but the week after that, right?
Yeah.
Okay, yeah. So I think I have to look at what date I want to do it, but I'm thinking we might do our midterm the Friday right before spring break. Let me think about that, but if you want to start mentally preparing for that, that might be the way it goes. So that's what, 2 weeks from today, I think. Is that correct? Is that Friday? Okay. That's kind of where I'm thinking right now, so that the stuff is still fresh in your mind before you've gone and vegged out for a week and then come back and forgot everything. All right, questions, comments, concerns, bribes. Bribe? What's up?
So right now, the enemy, the monster,
They're not even running into the walls. Right now, they're just claiming they want to go to the north or east. They're just saying it. They're not actually trying to go anywhere yet. That's what you have to write. Yeah, but right now right now they are randomly picking a direction they want to try to go. So I want you to take that direction and actually try to go.